These are examples from Lesson 8.1. In this video, you will learn how to perform single transformations, one of three types. Transformations can be performed on a simple plane or on a coordinate plane. When performed on coordinate plane, you can use formulas to find new vertices. Example 1. Name the type of transformation demonstrated in each picture. Remember, objects translated only move horizontally and vertically. Reflections have a line of symmetry, and rotations turn around one single point. Part A. This figure has been flipped or reflected over this line H. So this is a reflection about line H. Part B. The same figure has been rotated or turned in a clockwise fashion about point C, or about point P. So this is a rotation about point P. In the third one, C, the same figure has been translated, or there's been a slide going eastward or east, or directly in a horizontal direction. So this is a translation Example 2. Figure ABCD has the vertices A, -4, 3, B, -2, 4, C, -1, 1, and D, -3, 1. Sketch the pre-image ABCD and its image A', B', C', D' after the translation given by the rule XY translated to X plus 5, Y minus 2. In this form, A is 5 and B is -2. A indicates the horizontal shift and B indicates a vertical shift. So starting with the ordered pairs, A, B, C, and D, we translate and we add. This will be A prime. We take the X coordinate, -4, and we add 5 to it, comma, and then the Y coordinate, 3, we subtract 2 from it. And this gives us A prime is at 1, 1. Point B at -2, 4 translates to B prime. We take the X coordinate -2, we add 5 again, comma, take the Y coordinate 4 and subtract 2 again. This gives us B prime at its new location 3, 2. C, originally located at -1, 1, translates to C prime. Applying the rule, we have our X coordinate plus 5 once again, comma, the Y coordinate, we subtract 2 once again. This gives us C prime at 4, -1. And finally, D, originally located at -3, 1, translates to D prime, taking the X coordinate -3, adding 5 to it, and the Y coordinate 1, and subtracting 2 from it. This gives us the new location at D prime at 2, -1. Now to graph them, we take the original points. This is the pre-image, points. Graph them carefully. A is at -4, 3. 1, 2, 3, 4, 3, 1, 2, 3. B, -2, 4. C, -1, 1. And D, -3, 1. Take a straight edge, carefully connect all vertices. This is a quadrilateral, so it has 4 sides. Then to translate, this will be our image. And we plot those points, starting at the origin. A prime is at 1, 1, right 1, up 1. So A has moved from this location to this location, A prime. It is, of course, moved 5 units to the right and 2 units down. Then we go on to B prime. B prime is at 3, 2. Plot that point. There's B prime. C prime at 4, negative 1. And D at 2, negative 1. D prime. Take a straight edge, and again, create the translated quadrilateral. So quadrilateral ABCD has been translated to quadrilateral A prime, B prime, C prime, D prime using this rule right here. Now attempt practice 2. Example 3, cross-stitching. You are drawing a pattern for a cross-stitch design. Use a reflection in the y-axis to draw the other half of the pattern after plotting the pre-image points at A02, B negative 3, 2, C 1, 0, D negative 1, negative 1, and E 0, negative 2. So first we plot these points at A at 0, 2, 0 left to right, up 2. So there's A. B is at negative 3, 2. C is at 1, 0. D is at negative 1, negative 1. And E is at 0, negative 2. So from A to B, from B to C, from C to D, and from D to E. Taking those ordered pairs and they want us to reflect in the y-axis, so we're going to use this rule. X and Y, such that there's a reflection across the y-axis, and the rule across the y-axis, the y-coordinate stays the same. You multiply negative 1 times the x-axis, or the x-coordinate. So this is the rule we're going to use on each and every point. So here's A, B, C, D, and E. A was at 0, 2, so we make across the y-axis, we reflect to get A prime, and we multiply negative 1 with the x-coordinate, comma 2. That gives us A prime at negative 1 times 0 is still 0, 0, 2. So it's going to be in the same location. A is at is at 0, 2. So 0 left to right, up 2. So A prime is still at the same location. Then B was at negative 3, 2. Across the y-axis, a reflection occurs. And we have B prime. We multiply the x-coordinate with negative 1, and we leave the y-coordinate alone. That gives us B prime at positive 3, 2. Negative 1 times negative 3. So our new B point location is at 3, 2. Start at the origin, 3 to the right, up 2. Right there. C. C was at 1, 0. reflecting across the y-axis. C prime, we leave the y-axis, the y-coordinate alone, multiply -1 with the x-coordinate. -1 times 1. That gives us C prime at -1 times 1 is -1, 0. Plotting that point, C prime, start at the origin, go to the left 1, and don't go up or down, 0. There's C prime. Now as we start connecting these from A prime to B prime, from B prime to C prime, for point D was at -1, -1. We reflect across the y-axis, we get D prime using the rule. We leave the y-axis by itself, and we multiply the x-axis with -1. -1 times -1. That gives us D prime at -1 times -1 is +1, -1. Plotting that point, start at the origin, go to the right 1, and down 1. There's D prime. Connecting C prime to D prime. And finally E was at 0, -2. Across the y-axis we reflect E prime using the rule. Y-coordinate stays the same, -2. And we take the x-coordinate and multiply it with -1. Once again, the y-coordinate, or the x-coordinate, stays the same because -1 times 0 is still 0, and the y-coordinate is still -2. So E prime is at 0, -2, start at the origin, go left to right 0, down 2. And so here's E prime. Connecting D prime to E prime, and we get this cross-stitch design. Looks a little bit like a medical insignia. Now, you try practice 3. Be careful because you're reflecting across a different axis. Okay, now some examples with rotations. Example 4. Graph quadrilateral ABCD with vertices at A, -2, 4, B, -4, -1, C, -3, -3, and D, -1, 0. Then rotate the quadrilateral 90 degrees about the origin counterclockwise and sketch the image A prime, B prime, C prime, D prime. Okay, first of all, we graph the coordinates for points A, B, C, and D. Let's go ahead and get these on here. C, -3, -3, and D at -1, 0. Plotting these points, A is at -2, 4, to the left 2, up 4. B is at -4, -1. C is at -3, -3. And D is at -1, 0. Connecting those vertices, we have a quadrilateral in this particular shape. We do a turn or rotation about the origin. There's our point of rotation right there. 0, 0. A 90 degrees rotation. The 90-degree rotation means that we're going to take X and Y and perform a rotation 90 degrees so that the Y coordinate becomes negative and the X and Y switch or reverse order. So that would be -y, x. So this is the rule we're going to use for all 4 points. Starting with A, to find A prime, 90 degrees. We take the X coordinate, which is -2, is going to reverse with the Y coordinate, but we negate the Y coordinate first. So this becomes -4, and so A prime is now, instead of -2, -4, is at -4, -2. We negated the y coordinate, and then we flipped both of these, and this is what we got. Now let's do the next one. 90 degrees, B prime. Again, we negate the y coordinate, so -1 becomes +1. So we have -4, 1, and then we flip those coordinates. So now we have 1, -4. For C prime, 90 degrees about the origin. Again, we negate the y coordinate, so -3 becomes +3, and then we reverse or switch the order, and we get 3, -3. And then finally D, 90 degrees, D prime. You can't, 0 doesn't have an opposite, so 0 stays the same, but you still flip the x and y coordinates. So even if you try to negate 0, it's still 0. So now we have 0, -1. The x coordinate stays the same. Okay, so now we're going to take these coordinates and plot them for our image. This was our pre-image over here. So we take the first point, A prime, at -4, -2, starting at the origin, -4, -2. There's A prime. So A prime has rotated from this point counterclockwise, has gone around this way to this point right here. B prime is at 1, -4, so we go to the right 1 and down 4. 1, 2, 3, 4. There's B prime. So B has moved, has rotated from here over to here about this point O, 90 degrees. C prime, 3, -3. Start at the origin, go to the right 3 and down 3. 1, 2, 3. This is our C prime, our new location for C. From the origin, it has rotated 90 degrees counterclockwise. And finally D is 0, -1. Start at the origin, go left to right 0 and go down 1. There's D prime. D has rotated 90 degrees about the origin point to this location right here. Take a straight edge and connect A prime, B prime, C prime to D prime and back to A prime. And A prime, B prime, C prime, D prime is the 90 degree counterclockwise rotation about the origin of A, B, C, D. And you try practice 4. Example 5. In the description of a translation, points 2, 0 and 3, 4 are two vertices of a triangle. If 2, 0 translates to 4, 1, then 3, 4 translates to what point? One way we can do this is a translation. We take our original points, which would be 2, 0 and 3, 4. 2, 0 translates to 4, 1. So we've got a complete picture of what happens here in this translation. But for 3, 4, we don't know what it translates to yet. So we take the original point, 2, 0, and see what we use to translate to 4, 1. One way we can do this is by taking both the pre-image point and the image point and this is pre-image, this is image. And we create an equation out of both. We take 2, something has happened to 2, we have added some amount A to get the new x-coordinate 4. So we have 2 plus A equals 4. And then with the y coordinates, we start at 0 and we add some number b to get 1, the y coordinate. And so our equation is 0 plus b equal 1. Solve both one-step equations. On this one, you subtract 2 from both sides, and a equals 2. Over here, 0 plus b is simply b, so b is equal to 1. So a is 2 and b is 1. And so if we use the new rule that was created by this, which would be x plus 2, comma, y plus 1, that's where I'm getting these two numbers, and apply this to our second point, 3, 4, we take 3 and add 2 to it, comma, and then we take 4 and add 1 to it. And so our new point is at 5, 5. So 5, 5 would go right here. Example 6. Use coordinate notation to describe the translation that's given. 5 units to the right and 3 units down. So, you know, in the form for the translation, its formula, is x and y, such that there's a translation to x plus a, comma, y plus b. So identify a and b. A, it says 5 units to the right, which is horizontal. Right implies positive, so A is positive 5. And then it says in 3 units down. 3 units down implies negative, so that would be B is negative 3. And then simply substitute in those values in A and B and simplify if needed. So we have x, y, such there's a translation to x plus 5, comma, y plus negative 3. Well, plus negative 3 is really just minus 3. So we get, this is the rule that we get, x, y, such that there's a translation, so that x plus 5, y minus 3. And that is the translation rule that describes this right here. Now you try practice 6. Example 7. The point 2, negative 4 is an image of a transformation given. The rule x and y, such as this transformation, so that x minus 4, comma, y plus 3 was used to find it. What was the pre-image point? So in this one, we're going backwards in a sense. What we can do is we can take the rule here, and you know, x, y, x minus 4, y plus 3, and that's going to equal our final image point, which they gave us. This is what we got after the transformation was made, and set that up. Now we take this and this, because these are the two x coordinates, and create an equation. X minus 4 equals 2. And take the y parts, both of them, and create another equation where you use this, y plus 3 equals the y coordinate here, negative 4. And solve both equations. Add 4 to both sides here, we get x equals 6. We subtract 3 from both sides over here, and we get negative 7. And so our original point was at 6, negative 7. So 6, negative 7 is the pre-image point. Example 8. The point negative 3, 1 is an image of a transformation given. The rule x, y, such that there's a transformation to x, negative 1 times y, was used to find it. What was the pre-image point? So this one's a lot like the one we just did, except it's a different sort of transformation. What kind of transformation is this? It's a reflection. Over which axis? Over or about the, what is it? X-axis. It's the axis that they didn't manipulate in the rule. Since y is being changed, it was the x-axis. So now that we know that, we can do something similar that we did a while ago. We take the rule, and set it equal to our image point. They gave us the image again after the transformation. We set both x coordinates equal to each other. X equals -3. And both the y coordinates set equal to each other. -1 times y equals 1. Solve in both cases. This one's already solved for. And then this is -y equal 1, or simply divide both sides by -1, and y is -1. So our original point, or our pre-image point, was at -3, -1.